This is the first video in a short series on building out the sound card for my 286 system. Previously I had shared a video where I was working on the PCB design for this. I ordered up that PCB and I've been sitting on it here for a week or two, just haven't had time to really look at it. But now that I got my onboard ROM updating working on my 286, I'm now going to shift over and try to get this sound card working. And then I can maybe from there pivot into a whole bunch of assembly work that needs to get done on my 286. So I've got two ISA slots on my board. One obviously is the video card. The other slot is where this sound card is going to go. And I'm going to just walk through the basics of this sound card and give a little bit of background on it. First things first, I wanted to not get ahead of myself and populate the entire card and find out I had some issues with this design. So I'm going to build it out in stages. And the first stage is what you see here. I have put in really I'm going to call it the audio coprocessor of the system. And that processor is a 65816 processor. I then have the RAM that goes with it, the ROM. I have a versatile interface adapter, which I'll use to control a couple of these programmable sound generators. I have another PSG controller that's another VIA over here, and this VIA will control the other PSGs. So between those two VIAs, I'll control 6 of these PSGs. And then I have one more VIA that's going to allow me to control an SD card reader that's sitting here. 2 of these VIAs have an extra port, so I technically could have gone with one less VIA, but I wanted to have a debug port for controlling an LCD so that as I'm working on this card, I can debug it. Once I get all of the card dialed in, obviously that LCD will get disconnected and I'll have a free port there. And I still have a free port over here that I could do something else with. Other things that you would see on here beyond that SD card for storing media is I have an additional larger ROM that I can put in here that will store additional media. And so that'll be another one of these ZIF sockets that'll sit here. I yet need to put in some dual port RAM, and that dual port RAM is kind of a bridge to communicate between my 286, which can speak to the left side of the RAM or the outside of it. And then the sound card is going to work on the right side or inside of those dual port RAMs. And that will allow the 286 to basically drop off commands or information or music data, song data, whatever it might be, into that memory. And I have far more memory here than I need, but it'll give me some room for doing things in the future. And then these programmable sound generators, each one of these has 3 outputs. I think sometimes people refer to them as voices. So I have 3 different channels per. And so that gives me a total of 18 channels. And really what I'm going to do with that is I have 4 of these. And with 4 of these, I can do quite a bit. I've built some music in the past, I guess. And 4 of these is probably more than I need, or it is what I need, I should say, based on what I've been doing in the past. But that gives me 12 channels. And I either can go 6 by 2, so 6 channels left side, 6 channels right side, or I could go, if I wanted to, 12 channels in a mono. I think I'm going to try at some point to do some stereo type of things or stereo effects, things like that, where maybe there's something that plays on the left channel of the speakers and something plays on the right side. And I still want to have 6 voices per left and right channel. So that'll give me these 4 PSGs to get that done. And then I'm going to save 2 PSGs up here for effects, so sound effects. So these 4 down here, let's say mostly are going to be for music. These will be for effects. The ROM over here for media is actually accessed through a pair of these PSGs. So they're doing all of the access of pulling the ROM data. And from my 65816, then I talk to the PSGs. So it's actually a couple hops here. I go from the 65816 to a VIA to PSGs to the ROM. And I just did that because I have all of these PSGs, they have a whole bunch of I/O pins on one side of them that I'm really not using. And so I thought I would just experiment and try. Could I use a couple of these to, take advantage of controlling this ROM and not need something else on my system over here to deal with that? And that actually is working out very nicely. The other thing, at some point maybe in the future, I could use some of the other I/O pins on these other PSGs for keyboard, well, maybe not keyboard, but joystick. some sort of keypad, let's say, or joystick that I might use for game controller type of things. And those could plug into these PSGs quite easily. And I've got an older video where I hook up both a joystick and an NES controller. And that type of input would be really easy to add to this or to one of these ports on the VIA. So I have lots of flexibility there. I think the only other thing I'm missing on here, that I'll have to plug in is that you can see there's a bunch of empty DIP sockets. This has to do with the basically memory address that I want to set for the dual port RAM so the 286 can talk to it. And also there's an I/O port so that I can interrupt the sound card from the 286. Which probably sounds backwards, but from my 286, I want to be able to maybe drop off commands in a queue on the dual port RAM, and then trigger an interrupt on the 65816, the audio coprocessor, then to go process those commands. And so I've got logic here that just makes sure I'm decoding everything correctly and only accessing this memory from the 286 when I should be, based on the address. And I'm also setting up a register, and I have a register set up that will help me trigger the interrupt on this. And of course the decode logic to make sure that when I write to the proper I/O port, it gets to that register that's sitting here. So I've got a lot of functionality here. I can talk from my 286 to the 65816. I can go vice versa. I can interrupt either way. I have lots of channels available for sound and effects and I/O. And I've got lots of storage for SD card and basically flash memory. Either of those I can leverage as I need it. I didn't want to populate all of that and find out I had some issue with the core. Now this is an evolution of a previous card that I had built for my 65816 computer. So I have a 65816 computer that had this card in it, or a previous version that has its own 65816. This one's a little bit different. Obviously I'm going x86 over to a 65816, but same concept. It's just a secondary processor. So this card is expanding on that. I wanted to make sure the core still works before I start getting into the rest of population of all of these sockets and dual port RAM and things like that. So that's what I'm going to show right now, is just kind of getting that part of it going. Now, if I take a look over here at the schematic, the things I've walked through, and again, I'll have this schematic posted on my blog. I have a blog post for the sound card in the last month. I'm going to just kind of append to that post here as I work through this. But down here is all this logic as far as the decode of the address and the I/O. I've got the ISA edge connector here. I have dual port memory sitting here. And then a lot of what you see right here is the core. And that would be the processor. That would be the ROM, the RAM, an inverter that I'm using for part of my logic here, and then this GAL PLD. And then I'm so far populating one of these PSGs over here. And I'm not zooming in. The details don't matter here. If you're interested, you can go look at the schematic. But just showing that so far I have this much, what you can see in red. I have this much populated. And so there's a lot to populate yet, but I want to make sure this much worked. Now one change, I did change the logic on my PLD from my previous sound card. And the way I built out that logic is I just used Excel. I came into Excel and I laid out, some columns here. What's the purpose of a certain memory address? Where does it start? Where does it end? How big is that chunk of memory? And then kind of tallied up my total so I could get to a total of 64K, 32 of which is RAM, another 32 is my ROM. So not a lot for RAM or ROM, but for a 65816 build, that's plenty for what I'm going to be doing for sound. And then I just show what addresses have to be set accordingly for that decode to be working. X means I don't care. So this, anytime that the address starts out with a 0000 something, I know that that's the beginning of my RAM. And I know that goes all the way up to this pattern 0101 something, and that takes me through 5FFF. So I have 24K of usable RAM. I have 4K in the dual port static RAM that I'm going to be using here. So there's 2K each. I have a pair of them. That'll give me 4K. There's a little bit of wasted space that I'm not using here of 2K. The VIAs each take, they are memory mapped, so they each take some of the address space for my 65816. I have a bunch of unused. Well, I shouldn't say a bunch of unused. It's actually not a lot space-wise, and it's just 1 1/4 K that I'm wasting in these address spaces. But then for all of these, I then have this little matrix over to the right that just says, okay, if this is true, RAM should be enabled. It's an active low, so that's enabled. And I can see that's enabled all the way down through here. And if this is true, then my output for the dual port RAM should be enabled, etc. And I work my way over. Any of these ranges, nothing should be enabled. Same with this one up here, nothing should be enabled. And if I'm down here, then my ROM should be enabled. So I took this, copied it over, and put it into a format that looks like this. It's the same thing minus some of the extra just notation and stuff, or information. But this I can now pull into a tool called Digital. And in Digital, I just simply import that as a CSV file, essentially. And then Digital will create the logic for me. So it actually then built this automatically. I didn't have to build any of this. And then from here, I can go out and say that I would like to basically have it build. And actually, let me go back here. If I go back to the previous thing that I had up, which was this table, from that, I can actually have it create the file for my GAL. And if any of you have worked with these GALs before, the software that typically is used for them, I'm going to say is terrible, and I do everything I can to avoid it because it is so bad. But this software will actually create the file that I need so that I can go straight over to my programming software and load up that file and burn it directly. And I don't have to go through some of these other utilities for these GALs. I do have a post on my blog about creating GALs using Digital, and that's the name of this software. So if you're interested, go take a look at that, or if you can't find it, let me know and I'll point you in the right direction. So I create it in Excel, I import it, it creates this. I then create the appropriate file, the image to actually burn to the chip. I take this chip, I put it into my burner up here, and I burned it, and I put that in. So that got me up to speed to have, what you're seeing in this view right here. So that is the address decode that I am using within the sound card. And you can see I obviously hooked up an LCD to this port here, and I'm doing this nibble mode where I work with the data 4 bits at a time instead of a byte at a time. But that way I can do all the control signals and the data signals off of one port on my VIA. It doesn't require 2 ports. I wanted to use a single port. You'll also notice that as far as power for now, I'm just bringing in a power line straight from my power benchtop power supply into one of these quick connect adapters on the card. Later, that power, of course, will come from the ISA slot. The other thing you're going to notice is that I have a pin of my processor connected basically to ground. And this was a small resistor. I didn't even measure what the value is. I know it's sub 100. It's in I pulled it from my little drawer of miscellaneous resistors that were labeled sub 100 ohms. So it's a small resistor, but I'm pulling this pin to ground. And that is actually my reset pin. So when I apply power, it's going to be pulled to ground, and that is an active low. So this will stay in a reset mode until I pull this wire. The reason being is I need somewhat of a delay. You need to keep that reset low for a little bit to let the processor initialize before you let it go high and let it start running. And if I don't do this and I turn on the system, it's not going to fire up correctly. Now later, of course, that signal for reset comes from my ISA bus, and on my 286, I have a chip in here that does that delay. So I'll be good once this is actually in the system, and this is unnecessary. But for now, I'm going to test this card just like you see it, just sitting here on the bench. And I'm going to go ahead and turn on power at this point. And power comes up. I'm going to now pull off that reset. So it's now brought back high is essentially what happened. The processor pulled that high. And you can see my debug output says ready. So that tells me this is working, because for that to have worked, the decode, at least for ROM and RAM and the VIA, had to work. My ROM had to work because that's where my code is. The RAM had to work because I'm doing calls to subroutines and things like that. So it's using a stack. And this inverter had to work, and my oscillator. So all of those pieces that you see there are working. I I can't type or do anything like that at this point. You know, it's just a core processor system running, ready for the rest of these components. Now it is interesting. I had to remember it's been a while, and when I say this, it's all relative, right? But it's been a while since I've done 65.816 programming. I've been on this 286 journey for a while, and before that I was working on my own custom 16-bit processor, and I wrote my own basically opcodes and everything as I built that processor, and the assembly I was doing for that was essentially my own custom type of thing. But before that I was doing 65.816 projects, and before that 65.02. But I had to remember, I had to go dust off a tool here, and the tool that I'm using for this coding is Visual Studio Code. So if you've been watching my 286 series, I've been using Visual Studio 2022, but for this I'm using Visual Studio Code, and the reason is I'm using this retro assembler, and this is just how I initially set it up. And I might need to just get this switched over to Visual Studio because the keyboard shortcuts in Visual Studio Code drive me crazy, and I so much better appreciate the ones in 2022, and it's just what I'm used to is why. It annoys me to have to go back and forth between these two environments and have inconsistencies in keyboard shortcuts. But in this, I basically have a directory for all my sound card stuff, and I have an assembly file that I'll be spending time on, and at a later stage I'll walk through some of that assembly. But maybe for now, just to say, I have this assembly here that does things like initialize my LCD when the system starts up, initialize sound, play a sound, which right now obviously that's not going to play a sound because it's missing all of the components to actually play that sound. And then I have a bunch of SPI. If you watched my videos on using SPI on my 286 to get to the SD card, here I have something similar implemented. It's just in 65.816 assembly instead of x86 to go out and access this SD card over here. So I'll be able to work with that, and that's what a bunch of these commands are for. I can read from the dual port memory. I can manage the IRQs, things like that, the interrupts, all that's working. And over here, I do have a separate file that manages the LCD. I have a separate file to track all of my variables. I have a separate one that's going to get in and help me with actually playing music. So there's quite a bit I can do with this. And again, I posted on it previously on some of the music type of work that I've done to be able to play back music, or even capture source of what music looks like to be able to play back. Something in the future, I can spend some time walking through some of this for those of you that have interest in learning more about that. But that's kind of all I wanted to show for now. And so I have the PCB started to be populated. I have the core pieces in. I'm running a 10 megahertz clock for the core. I have the logic put onto my GAL. That seems to be working. And I have test output, so when the system turns on, if I'm seeing this output, that tells me things are working pretty well here. So I am happy with that. In the next video, I think what I'll do is I will continue to populate, and I think I will get my VIAs and the PSGs populated along with some content on either the SD card or the ROM, and see if I can get some audio output. That audio jack will sit over here. If I make it through that, then I will connect in the dual port RAM and all of the other parts that'll be needed to connect into my 286 system. And I can test that as a standalone card, and then of course to plug it into my main system and see if I can make it work, talking from the 286 to the 65.816 to generate output to go out my stereo output here. So step one, I have at least a few more steps to go before this is going to be working, but I'm going to try to break this into smaller chunks as I go.